today I want us to undergo the optical phenomena and properties of materials, and we're going to be discussing the emission and absorption spectra. Let's start with the atomic absorption spectra. Now that one happens, don't mind the pen. Now that one's going to happen when, so let's first get something straight. A white light passes through a prism, and when it passes through the prism, all of its frequencies are now visible. This is in the form of the rainbow colors. So from red, orange, yellow, green, blue, don't forget indigo and violet too. That becomes visible, and when it's just as is, it forms the continuous emission spectra. That is going to look something like page like this. Just imagine this without any of the black lines. Just a nice that's the continuous emission spectra. Now we're going to move to the atomic absorption spectra. Now, one sec. What is the atomic absorption spectra? Now, how you just need to know how it forms, because according to this little guy, the atomic absorption spectra is formed when certain frequencies of electromagnetic radiation passes through a substance and is absorbed. So certain frequencies of electromagnetic radiation pass through something where it's absorbed. So let's say we shine the light through the prism again, and then you get all your rainbow colors. And then, but then the light, it goes through a cold gas. And in the cold gas, there are certain energy levels. The cold gas is made out of atoms. Those atoms have certain energy levels. So we have the N1, N2. These are the energy levels. And N3. Now over here, let's say it's 1 joules. It's kind of like this. Here's the nucleus, and here are the electrons, the particles, if you will. Here's one energy level. Here's another energy level, and here's another energy level. We're going to put it in the form of this graph. Now over here, when the particle, the fungi over here, they are electrons, and we say atoms in this case. They what is it here? There are photons here, and there are electron particles over here. The particles absorb the energy of, no, not yet. Before we get to that, let's first talk about over here. Let's say there are 3 joules, and over here there are 5 joules. Now, to jump from here to here, what does it take? From energy level 1, the ground state, it takes 2 joules. Here is a difference between 2 energy levels. Then to jump from 3 to 5, it takes 2 joules again. I don't want it to take 2 joules. Let's make this 9 instead. 9 joules, yes. So that's 6 joules. To jump from 1 to 9, that's 8 joules. And then to jump, I think that's the furthest we can go in regards to getting up and going higher. So here are the differences in energy levels. When the light shines its frequencies, let's say it has from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 joules. Let's say all of these frequencies comes in the form of 1 joule, 2 joule, 3 joule, 4 joule, 4 joule, bang, bang, bang. These are actually frequencies, but we're going to convert it into energy. So that maybe this joule is like 12 hertz or whatever. Mind you, the frequencies we're converting it to energy. It's already energy. We're just going to look at it as energy. Anyway, now we see here we have the difference between energy levels. There's 2 joules. So 2 joules will be absorbed. There will be 6 joules. That's the difference between energy levels. 6 joules will be absorbed. And there's a difference between energy levels again is 8 joules. 8 joules will be absorbed. In this case, the electrons are gaining energy. Yeah, they're always going to be gaining energy. Yeah. Yep. They're always going from a lower state of energy to a higher state of energy. Now back to this. Here are the 3 differences in energy levels. Those energy levels will be absorbed because those differences, it's actually the electrons basically going from a lower state to a higher state. When it goes up to a low state to a higher state, it's absorbing the specific energy, which is the specific frequency. It's absorbing the specific frequency of 2 joules. Over here, when it goes from this state of energy to this state of energy, and then over here it's absorbing 8 joules when it goes from this state of energy to this state of energy. And when that happens, it's absorbing these specific energy levels. So when you have your little emission line right here, I don't like this light. I want to go find a different light, maybe some sort of ring light type thing. And then so over here, which ones are here? There's going to be 1, 3, 4, 5, 6 is gone, 7, 8 is gone, 9, 10. 8 is good. The space that should be for 8 will be a black line. 8 has been absorbed. It won't be part of the continuous spectrum. 6 is one of the differences as well. It's going to be absorbed. It won't be part of this thing. And 2 will also be absorbed. It won't be part of this thing. And that's how we form that weird looking line thingy. So what's the description? The spectrum observed is a continuous spectrum with dark lines where the characteristic frequencies of light are removed. The frequencies of the absorption lines are unique to the type of atoms in the gas. Remember, these are the type of atoms. The type of atoms have this energy, have these energies. So that's what they mean when they say it's unique. I just crammed it, but this is my way of understanding it. Feel free to go, since I'm on YouTube now. Woo! Feel free to go to the comment section and correct me. I accept all criticism. Anyway, so that was the atomic absorption spectrum. And just know, for baseline, the atoms go from a lower state of energy to a higher state of energy. It involves a cold gas, and it has gaps, and it will be a continuous emission spectrum, but it will have gaps or dark lines where the characteristic frequencies have been removed, which is the difference in energy levels. Now let's move on to one of my favorites actually. For this one, I'm going to add a little pop of color, because why not? This whole country is bumming me out. Now we move on to the emission spectrum. The emission. Atomic emission spectra. I say it all those times, I still didn't get it. Now over here is formed when certain frequencies of electromagnetic radiation are emitted due to an atom making a transition from a higher state of energy to a lower state of energy. See, why can't they write this one more easily like that? So here's what's going to happen, my dear. So there'll be a light, and that light, it will have like a potential difference is applied, which means it's a positive and a negative terminal, basically. And then the lights will shine through that positive and negative terminal. When that happens, these, they're gonna be like this. Here's one name. There's gonna be like this light bulb type thing. It's gonna have hot gas inside. Let's say hot hydrogen gas. And then, the description is right here. It's beautiful. Atom emits frequencies and characteristics. Anyway, it'll have this light filled with hot gas. I don't have a Google picture at the moment, but once I get these fancy editing apps, I promise to pull up with a pic. But there'll be a light bulb filled with hot gas, and they switch on the switch manager. There's a positive and negative terminal. The current flows through this gas, and as it does, the current collides with the electrons and gets in excited state. So the current, what's the current measured in? Which are electrons. They collide with the electrons that are in here. The lights, and then so the electron gets to an excited state, basically. So the electron, let's say the electron is here. That nigga's excited. excited. It's absorbing all the energy from this, like it's getting excited. But that because it's colliding with the currents, it's going to collide with the electrons. The electrons are like whoopee, and they excited. They gain so much energy. And then, like, let's say this guy, he was here at first, and then he goes all the way up here. So that's 9 minus 1. It's like the top one, the one that we did before, where it goes from where due to the cold light, where the photons are going to pass the cold gas, and then like the atoms are going to absorb the photon and gain energy, and then like it's gonna absorb the energy of the difference between the energy levels. Yeah, that one. Where it's gonna be like 2 minus 5 and 3 joules, basically the one that's gonna be absorbed. Over here though, since all the particles are getting so excited, they're going to gain a bunch of energy, like the top, but this time they won't stay excited. When eventually it's gonna get unexcited, de-excited, bummed out. It's gonna get bummed out. So it's gonna get removed from this excited state, and then it's going to transition to its low state of energy. From 9 to 8 joules to 1 joules, that's 8 joules. So 8 joules of energy will be, let's say, yeah, mind you, these energy levels are different for every gas. This is just, let's pretend like this is hydrogen. It's not really hydrogen. So yeah, and then when it goes back down to its normal state, it's going to release energy. The energy from 9 joules to 1 joule is going to release that energy as 8 joules. And those 8 joules will be now visible right here. And let's say those 8 joules gave us blue. So now, don't mind this. I was trying to be cute and stuff, but then I know this 8 joules is going to be visible. So this is your 8 joules being released right here. Oh wait, I should probably make purple 8 joules because like it has the highest frequency. Yeah. So let's make this 8 joules because it has the highest frequency. Purple, indigo, violet, whatever. I don't have the color violet. Okay, then let's say it went from, this is a different electron, it went from excited state to 5, and then it was all excited, and then it went from its high state of energy to a low state of energy. 5 minus 1, that's 4 joules. The 4 joules will be the blue, because that 4 joules is released into the world, and you can see it right here. Then my brother went from 1 to 2 and back down, was excited. Then it went from its high state of energy to its low state of energy. 2 minus 1, that's going to be 1 joule. We got a 3 joule anywhere? Yeah, we got a 3 joule. When it goes from here to back here, papelan. And then that's going to be your 3 joules. Let's make that 3 joules. Really? Do we have anything else? 9 to 2. That is going to be a nice 7 joules. We already got. Yeah, we're going to make you 7 joules. We're going to make you the 4 joules, just so it can align, so that you can remember that higher energy to lower energy. Then we got like 3 joules somewhere up in there, and then we got a 1 joule right here, just so it can line up. And this is your emission band. Atomic emission spectra. It goes from highest state of energy to a low state of energy. It's associated with a hot gas. You need a potential difference to be applied for this to take place. And yeah, that's the difference between the two. The questions about it are usually pretty tame. Usually. You don't know. They like to be cute and quirky in these exams. Anyway, thank you for another class with Miss Mkize. And yeah. I guess I have to say stuff like, comment, and subscribe, but then no. I mean, if I'm broke, you'll see it. You'll see when I'm broke. Like, broke. Maybe next year at university. Like, as for now, subscribe if you want to. I think I'm gonna continue doing this.